Okay, hello students. In this video, we'll continue in our chapter 14, normalization, and we reached till functional dependencies. And in this video, we'll explain the terms and explain what is a functional dependency. So first of all, we should define some terms. First of all, big R is the relation schema. We mean by big R the relation schema. We mean by R of R relation instance or set of rows or tuples in a relation. Okay, A1, A2, AN are the attributes or columns which belong to universal relation, and X and Y are sets of attributes. For example, X may be A1 and A2, and Y may be, for example, A3 and A4. Okay. What do we mean by a functional dependency? X, an arrow, then Y. We can read this as X defines Y, or X determines Y, or Y is dependent on X, or Y can be derived from X. So a functional dependency X determines Y between X and Y specifies a constraint on the possible tuples that can form a relation instance R of R, which means every row and every tuple we need to insert into the relation, it should conform to this functional dependency. Let's take an example. For example, in this relation schema, we have the relation schema named student and 4 columns: SSN, student number, the name, and the major. Here is the primary key is the SSN. Because SSN is the primary key, then if we know the SSN, then we can know the name, then we can know the student number, then we can know the major. So we can say that the SSN derives the name or the SSN we can or the name can be derived from SSN. For example, if we have two tuples that belong to the table or the relation student, for example, we have tuple T1 or row 1 and T2, which is row 2, and the same or the two tuples have the same SSN. This means that they correspond to the same student, which means they have the same student number and the same name, Ahmad. So in this case, we say that SSN determines the name. Another example is the student number determines the major, because the student number is a candidate key. In addition to the SSN, we choose the SSN as the primary key, and the student number remains as a candidate key. Also, student number determines the major. So if we have T10 or row 10 in the table, and we have this row has a student number, this number, then for example the major will be math. So if this number repeated again in another tuple or row, for example row 12, then the same major will be, or the same value for the major will be for this student. So in this way we can say that the student number determines the major. This is what we mean by X determines Y. So X determines Y. If we know the value of X, then the value of Y should repeat as long as the X repeats. Because SSN is the primary key of this relation schema, then we can say that SSN determines these sets of attributes, which is SSN, name, the student number, and the major. This can be decomposed for each attribute. So SSN determines the SSN determines the name and student number and the major. Okay, so the constraint states that for any two tuples or any two rows, T1 and T2 in R, such that if T1 of X equals T2 of X, for example, if the two rows have the same value for the column X, then they should have the same value for the column Y. Then T1 of Y equals T2 of Y. This means that Y component of a tuple in R depends on or determined by the values of the X component of that tuple in R. So we say that Y depends on or determined by the values of X component in that row, or the value of X component of a tuple in R uniquely determines or functionally determines the values of Y component. Okay, for example, if we have this relation managed between a manager entity and a department entity, and this is a one-to-one relation, so that one manager can manage at most one department, and one department can be managed by at most one manager. So if we know the SSN of this manager, then we can know the department he managed. And if we know the department name, then we can know the manager who manages this department. So we can write, if we have a relation schema manager and with 3 columns, for example, SSN name, the name of the manager and his SSN, also the departments he managed. We can say that the SSN determines the name and the department, because if we know the SSN of the manager, then we can know his name and we can know the department he managed, because we have a relation one-to-one. So at most one manager can manage a department, and at most a department can be managed by one manager. So the SSN uniquely determines the name and the department. Also, we can say that the department determines the SSN, as we say, because we have a one-to-one relation. A department can be managed by at most one manager. But we can't say name determines the SSN. This is incorrect functional dependency, because we may have two managers with the same name but different SSN that manage different departments. So the name can determine the SSN, because as we say, we may have two managers with the same name but different SSN. Okay. So functional dependency, or FD, is a property of the meaning or semantics of the attributes. It defines how the attributes can relate to each other. So functional dependency is specified as a constraint on R, which means that every row we can enter to this relation must conform to this functional dependencies. All extensions of R, which means the instances or set of rows of this relation schema, should specify that constraint, which we call them legal extensions in this case. Otherwise, if we have some rows or tuples in the relation instance R of R that doesn't conform to this functional dependency, we call them illegal extensions. Note that we cannot infer functional dependencies from the R of R. So if we have a set of rows or an instance of the relation schema, we can't get or infer the functional dependencies from this set of rows, because we may, for example, enter or insert a new row or tuple that break these functional dependencies. In the second video, we will talk how to get the functional dependencies from a set of initial functional dependencies. So see you soon in our next video. Thank you.